Okay, we've got meter, kilogram, and seconds. Now, if we think about starting with grams instead of kilograms here, we can put prefixes in front of the M, G, and S. For 1,000 meters, 1,000 grams, 1,000 seconds, we use the prefix kilo, or just K to indicate kilo. 1,000 meters is 1 kilometer, or 1 kilometer. 1,000 grams is 1 kilogram. 1,000 seconds, 1 kilosecond, which we then write as 1 km, 1 kg, or 1 ks. And let's keep in mind that means 1,000 or 10 to the 3 of the basic unit, 10 to the 3 meters, 10 to the 3 grams, 10 to the 3 seconds. So by putting this K in front of our unit, it means 1,000 of those things. 1,000 meters, 1,000 grams, 1,000 seconds. Well, we have more units, more prefixes that we can use. 1,000 kilo is a mega. In other words, 1,000,000 is 10 to the 6th, or 1 million. So 1 megameter is 10 to the 6th meters, or 1 capital M, lowercase m. Remember I said make sure you keep track of lowercase versus uppercase. So this capital M is mega, lowercase meter. 1,000 mega is a giga, or 1 capital G. And a giga, then 1,000 million is a billion. And 1,000 giga is a tera, capital T prefix, and that would be 10 to the 12th. So kilometer, 10 to the 3 meters, megameter, 10 to the 6th meters, gigameter, 10 to the 9th meters, terameter, 10 to the 12th meters. And you could have gigagrams, teragrams, gigaseconds, megaseconds, anything like that. You've probably heard of kilobytes, megabytes, gigabytes, terabytes. Those are all using these prefixes in terms of how many bytes you have. So it's a way of indicating larger and larger amounts of information, or storage capacity. We can also go the other way and use prefixes to indicate smaller quantities. We can have 1,000th of a meter, and this is a millimeter. Now we've got to be a little bit careful here because the prefix for milli, the abbreviation for milli, is a lowercase m. So we've got a lowercase mm. The first m is milli, the second one is meters. So 1,000th of a meter is a millimeter, or 10 to the minus 3 meters. Or 1 meter is 10 to the 3 millimeters. 1,000th of a milli is a micro. The symbol for micro is a Greek letter mu. I'll write that on the board in just a second. Greek letter mu. 1 micrometer is 10 to the minus 6 meters, or 1 meter is 10 to the 6th micrometers. 1,000th of a micro is a nano, abbreviation lowercase m, or 10 to the minus 9th meters, or 1 meter is 10 to the positive 9th nanometers. 1,000th of a nano is a pico, and a pico, lowercase p, 10 to the minus 12th, and 1,000th of a pico is a femto. That's a 1 lowercase f for femto, which is 10 to the minus 15th. So 1 meter is 10 to the 15th femtometer. So we're talking about very, very small things here. This is about the size of the nucleus of an atom. Now, let me just mention a femtometer, also sometimes referred to as 1 Fermi. So if you're talking about nuclear structure, a femtometer is sometimes also referred to as a Fermi. There's one other unit I'd like you to remember, and that's just because it's very ubiquitous. It comes up a lot, but it doesn't follow the same pattern of thousandths. And that is 100th of a meter, and that is a centimeter. So 1 centimeter is 10 to the minus 2 meters, or 1 meter is 10 to the 2 centimeters, or 100 centimeters. So, what do we need to remember? We need to remember nano, micro, milli, centi, kilo, mega. These are the ones that I really want you to remember. The centi is the kind of unusual one here. Let's remember nano, 10 to the minus 9th, micro, 10 to the minus 6th, milli, 10 to the minus 3, centi, 10 to the minus 2, kilo, 10 to the positive 3, mega, 10 to the positive 6. So while these are all important, these are the ones that I really expect you to remember. And by that I mean I will use these freely in lecture, and also if you're actually taking my class for credit, you will be seeing these on quizzes and exams, things like that. Okay, so there we go. Those are the units that we'll be using. How do we switch back and forth from, say, one unit to a different unit, from femto to kilo or something like that? How do we convert quantities from one unit to another unit? Let's take a look at that. In order to convert one unit to another unit, to do a unit conversion, we need a conversion factor. All conversion factors have the same value. They are all equal to 1. Just 1. No units, just 1. Now, how is that possible? What do we mean by that? Well, let me ask you some things. If I multiply something by 1, what happens to it? So if I take 2, or let's say 1/2. Say I have 1/2, and I multiply by 1. What do I get? Well, if you multiply anything by 1, you just get the same thing back. 1/2 times 1 is 1/2. Well, what if I take this 1/2 and I multiply by 3/3? Well, what's 3/3? Well, 3/3 is 1. So I'm still just multiplying by the value of 1. But in this case, let's multiply it like this. We'll multiply the numerators. 1 times 3 is 3. 2 times 3 is 6. So in this case, we started out with 1/2, but we ended up with 3/6. We end up with something that is equivalent to the original quantity, but it's in a different form. So 3/6 equals 1/2, but it's just written in a different way. Same quantity, but written in a different form. That's what happens when we do a unit conversion. We take one quantity in one form, we multiply by some form of 1, and we get an equivalent quantity back, but in a different form. In other words, from one unit to another unit. So let's try that. Let's imagine that we've got this quantity, 5.73 kilometers. And we would like to change this into a distance. This is some distance. We'd like to change it into a distance with meters as the unit. Well, we're going to make a conversion factor. Now, what do we know about the relationship between meters and kilometers? We know from the previous overhead that 1 kilometer is equal to 1,000 meters, or we could write this as 10 to the 3 meters. Keeping in mind this is a definition, so these quantities are exact. Now, what if I divide both sides by 1 kilometer? So I divide this side by 1 kilometer, and I divide this side by 1 kilometer. What do I get over here? Well, 1 kilometer over 1 kilometer, they cancel out, and I get 1. While over here, I get 10 to the 3 meters over 1 kilometer. So 10 to the 3 meters divided by 1 kilometer seems to be equal to 1. In other words, I've got equivalent distances in the numerator and denominator. If the numerator and denominator equal each other, they should give you a factor that's equal to 1. So I'm going to take this quantity and multiply our original distance by this quantity. And let's see what we get. So times 10 to the 3 meters divided by 1 kilometer. Well, notice, we've got a kilometer in the numerator and a kilometer in the denominator, so those will cancel out. And what do we end up with? 5.73 times 10 to the 3 meters. The kilometers canceled, but we're still left with meters. So 5.73 times 10 to the 3 meters. We have taken the quantity of 5.73 kilometers and we have converted it to meters, an equivalent distance, but now the unit is meters, by multiplying by a conversion factor that equals 1. So that's supposed to be a 1. That equals 1. We multiply it by a conversion factor whose value is 1. And that's how we convert units. Whatever the unit is, we can multiply it by a conversion factor and get another quantity that's the same quantity but with different units. Now, what if we had actually multiplied by, what if we had divided both sides by 10 to the 3 meters. Then we would get 1 was equal to 1 kilometer divided by 10 to the 3 meters. What if we had multiplied our 5.73 kilometers by this conversion factor? 1 kilometer over 10 to the 3 meters. What do we get in that case? Well, now the kilometers don't cancel out. They multiply. And we have to divide by 10 to the 3, so we get 5.73 times 10 to the negative 3 kilometers squared divided by meters. Well, is that right? Yes, that is right. This does equal that because all we did was multiply it by 1. It is not a particular useful quantity. It's not as useful as saying, typically, that 5.73 times 10 to the 3 meters, or 5,730 meters, is the same as 5.73 kilometers. It is true that this equals this, but this is not a particularly useful form for that quantity. We want to make sure to use the correct form of our conversion factor. Now, how do we know which one to use? Well, we've got kilometers in the numerator, and we want to end up with meters in our answer. So we need to cancel out the kilometers, which means we have to put the kilometers in the denominator of our conversion factor. So keep in mind, what do you want to cancel out? So where do you have to put the units in your conversion factor to do that? Okay, let's try another example.